we know that transition elements and their compounds are very widely used as catalysts in both organic as well as in inorganic reactions. So we'll be studying here the catalytic property. What makes them such good catalysts? We need to understand this. There are basic two reasons which makes them very good catalysts. The first is that they have vacant or partially filled d orbitals. Now in these d orbitals, what they do is, through these vacant or partially filled d orbitals, they provide surface area to the reactant molecules. They behave like heterogeneous catalysts and they absorb them on their surfaces by accepting their electrons in these vacant or partially filled orbitals. And this is how what they do is they decreases the activation energy of the reaction, because the energy released in this process reduces the EA and the rate of the reaction gets increased. So it's mainly because of the availability of these so many spaces which they have in the form of their vacant or partially filled orbitals. They absorb their reactant molecules by accepting their electrons in these orbitals, and they reduces the EA and increases the rate of the reaction. The another way of doing the same thing is that they have tendency to show variable oxidation states. Therefore, they exchanges electrons with reactant molecules. They exchanges electrons with the reactant molecules, and that is how what they can do is they can increase the rate of the reaction. To explain this, I can give you an example. Like, let's take a normal redox reaction between iodide ion and peroxydisulfate ion, in which iodide gets oxidized to iodine and peroxydisulfate gets reduced to sulfate. So it's like this. Now this normal redox reaction is a slow reaction, kinetically is slow, but it becomes very fast when it is allowed to take place in the ferric ions, which acts like catalyst. How it becomes fast? Let's see this. When we take this in presence of ferric ions, this reaction takes place in two steps. First, the ferric is the one which oxidizes iodide ion to iodine, and it itself gets reduced to ferrous. Now this ferrous ions in the second step formed reduces peroxydisulfate ion to sulfate ion, and it itself gets oxidized to ferric again. So what happens is, earlier without ferric, this one was the oxidizing agent for this one, reducing agent, sorry, and this one was the oxidizing agent for this one. Now when the ferric ions is taken, ferric ion becomes the oxidizing agent for iodide ion, and the iodide ion becomes the reducing agent for ferric, and similarly the same role is changed in the case of the second step. So what happens is E naught values get changed, due to which the delta G gets changed, due to which the K equilibrium gets changed and the rate of the reaction becomes very high. So it was due to the ability of the ferric to exist both in ferric and ferrous which makes it a very useful catalyst. So these are the two basic ways they increases the rate of the reaction, decreases the activation energy, and this is how they are very widely used as catalysts.